Hello and welcome to section 8.5. We are going to talk about partial fractions. And partial fractions are a way to break down functions and make the fractions a little bit easier to solve when we do an integration problem. And so my first example here, well, let's jump ahead here. So here's some setup that we can do. We divide if improper, we factor the denominator, and we decompose into partial fractions. So this goes back to what we were doing in earlier sections. If the fraction is improper, where the top is bigger than the bottom, we will divide, we'll do long division. If we can factor the denominator, we will factor the denominator, and then we decompose it into partial fractions. That's how we're going to go ahead and do this. That's the methods we're going to use. And then Heaviside's method is just a way of kind of getting the roots out of it and figure out what the numerators can be. And so that's just saying the Heavisides is just basically like, hey, I'm going to cover up this side, and we're going to solve for the zero and stuff like that. All right, so we have this method, and basically in that previous problem, we could have broken it up into, we had a problem that looks like this, and we did it, it can be done, this problem can be done either by trig substitution, which I didn't go through because for the length of the video, I didn't want to make this video too long. But you should look at this in the book and see how they do it with trig substitution. But then the other way we can do it is that we can factor the denominator, and we can go from there. So let's go through an example of this, of partial fractions and how this works. And so if we can kind of go through, basically what we have to do is, in this case, we have this quadratic, and so we would go ahead and factor it. And so if we were to factor the denominator of this guy, well, the factors of this turn into 1 over, what do we get? We get x minus 6 and x minus 1 as my two factors for this problem. Well, what we can do is basically we can break this into two different factors added together, because if I was to say a over x minus 6 plus b over x minus 1, and I went with common denominators for these guys, it would end up getting me back to something like this. So that's my first step, is I'm going to cross multiply these, get these as common denominators, and we're going to set it equal to the numerator. All right, and so this one's kind of a weird method because we have to do a little guessing and things like that as we go. So the first thing I'm going to do is I'm going to basically multiply this side by x by the common denominator, and I end up with a times x minus 1. Over on the other side, I'm going to be left with b times x minus 6. Well, if these guys are equal to the numerator, then we can get what a and b are, and we can figure out what the values are and make this integration a little bit easier. All right. So, with that being said, then now we're just going to this is where the wiggle room comes in this one. You can pick whatever x values you want and solve for the other one, but obviously there's better x values than others. For example, I'm going to pick x equals 1, and by doing that, that will zero out, so I'm left with a times 0 when I put 1 in for x, plus b times 1 minus 6 equals 1. Well, 1 minus 6 is negative 5. This guy goes away, so I've got negative 5b equals 1. And so if I divide by 5, by my negative 5, b will equal negative 1/5. All right, so well, knowing that, then I can do the same thing for a and solve for a. And so this time I'm going to pick x to be 6, and that'll zero out that value right there. And so I get a times 6 minus 1 plus b times 0 equals 1. And then the b goes away, so I get 5a equals 1. So a is 1/5. So I end up with this fraction of basically, now I've got this integral that I'm going to deal with, where I've got a is 1/5 over x minus 6 minus 1/5 of b, which was x minus 1 dx. And so then I'm going to go ahead and integrate this thing. And when I integrate this problem, when I go ahead and integrate this, basically remember that these guys are constant multiples. So I end up with 1/5 the natural log of x minus 6, because it's u prime over u. If this is my u value, x minus 6, if I take the derivative of that, I get 1, and so it just ends up multiplying by this. Minus the same thing, 1/5 of ln of x minus 1 plus c. And that is basically, that's the answer that we're going to be looking for as we go through these problems, all right? And so this is just an easier way. We would get to the same answer if we would have done trig substitution from the beginning, but it's way more complicated than this. All right, moving along then. So let's try something that looks like this. And in this case, still a quadratic. Still a quadratic here. And so with this guy being my quadratic, I'm going to integrate this thing. I'm going to do partial fractions, and I'm going to get the factors. And the factors are, in this case, x times x minus 10. That's my factors in my denominator. So then I'm going to write this as a over x plus b over x minus 10. Same idea, and you can pause the video here, and you can complete this and then come back to it, come back to the answer when we are done, when you think you have it. So in this case, again, I'm going to multiply these. So a gets multiplied by x minus 10 plus b times x, and that will equal 5 this time because that's the numerator. And so now if I go ahead and solve this, I get to pick some x values. Smart x value to pick would be 10 in this case. And picking 10 here gives me a times 0 plus b times 10 equals 5. And so basically b will come out to be 1/2. If I do the same thing with my a, and this time picking x to be 0, and again, these are just, you get to pick what you want here. That gives me a times negative 10 plus b times 0 equals 5. So it looks like a is negative 1/2. So this is kind of the same idea as what we just did before. So now I replace them and integrate the problem. So if a is negative 1/2, I'm going to put that over x, plus b, which was positive 1/2, over x minus 10 dx. And so now if I integrate this one, again, I get negative 1/2 the ln of x plus 1/2 the ln of x minus 10 plus c. And that is the answer. It just makes it way quicker and way easier to get through these problems. So in this next example, we're going to have some repeated linear factors in this case. And so this is just the method that we end up doing to go through and solve these problems. And it's kind of weird. But I'm going to go ahead and factor the denominator. So I get x times x squared plus 2x plus 1. And I can still factor this guy. And it factors out to be, looks like x plus 1 squared. All right, so now when I get a repeated factor, the setup is a little bit different, but I still do kind of the same. I still will end up doing the same thing. It's just that the top here is what we're going to be equal to, and which is very complicated. But in this case, I knew that I had to do something like this because the top wasn't bigger than the bottom, and so I have to factor, and we'll kind of work our way around this as we go. But, all right, so the way I set this up is I'm going to go a over x plus b over x plus 1 plus c over x plus 1 squared. And so this is what we do when we have repeated factors. We just repeat we get one single factor, and then we get one repeated factor. And so this is the way we would set it up, and just kind of keep that in mind. I know it doesn't seem to be logical with the way it's going, but because of the repeated factor, we kind of have to deal with it this way. So we will then multiply by the common denominator, which is this thing right here. We multiply everybody by the common denominator, which means a picks up x plus 1 squared, B picks up x times x plus 1, and C picks up the x, and that's it. All right, and then that is equal to our numerator, which is 5x squared plus 20x plus 6. Now we get to start picking some values to throw in here and try to make our lives easier. I am going to start with x equals 0, just because it seems like it's going to help me a lot here. If x is equal to 0, a gets multiplied by 1. If x is equal to 0 here, b becomes 0. So b becomes multiplied by 0. It doesn't matter what happens there. And c becomes multiplied by 0. And then over here, the only thing left is 5 times 0 squared plus 20 times 0 equals, so we get a is equal to 6. Well, that's helpful. That helps us a lot. So now I get to pick another value. And my next best educated guess on this one would be x equals -1. Seems like a logical choice. You should zero out some of the things that I've got going on here. So putting in -1, I get a. We could put 6 in for a because we know what it is, but since I'm putting in -1, that's going to zero out the first term there. If I put -1 in for b, that's going to zero out that term. And then c gets multiplied by -1, so it's c times -1. And then over here, if I square -1, I get 5. And then I'm going to subtract 20 and add 6. So it looks like -c is equal to 9. -9, or 9. Oh, that's supposed to be positive there. All right. Oh, no, it became negative because of the negative. So it looks like -c becomes -9. Sorry, I made a mistake there. C becomes -9, so C is 9. All right, so now that we have that, to find the B value, we have to pick something else. And it doesn't really matter what we pick, but knowing what A is and knowing what C is, we can kind of substitute all of these things in and just pick, you can pick any random X value you want. I always try to pick zeros and ones. Those seem to be the most logical one. So I'm going to pick X as 1. Knowing A is 6, I'm going to put 6 here, and then I'm going to say 1 plus 1 squared. And then B, I don't know, but I'm going to put 1 in there, and that becomes a 2. And then C is 9 times 1. And then if X is 1, I get 5 plus 20 plus 6. All right, and so at this point, it looks like I've got enough that the thing's solved for that I can actually find out what B is. And so this guy becomes 12. This is 2B, and 9 equals, looks like 31. So 2B plus, let's see, these guys combine together to give me 21. Oh, whoops, I messed that up. This is 24 over here. It is 2 squared, not 2 times 6, so that's 24. And so that makes things a little bit different here. So then that gives me that this one is 33. When I combine those together, equals 31. So if I subtract 2b equals -2, so b is -1. So now that I've got this all broken down, I can substitute it back into my partial fraction equation up here and get my answer. So I know a is 6, c is 9, and b is -1. So now at this point, I am going to try to solve this thing for what we're working on. So we've got a was 6 over x plus b was -1. B is -1 over x plus 1, and c was 9 over x plus 1 squared. There you go. So that's the actual integration problem I'm going to use. And so when I integrate this guy, I get 6 ln of x, and I could have made that the exponent if I wanted. I'm not going to at this point in time. This one becomes -1 ln of x plus 1. And then this guy over here is done with a u substitution, which makes it a little bit better when I integrate this guy. And it basically, if u is x plus 1, du is dx, so it ends up being u squared. So I'm basically integrating 9 times u to the -2 du, because that's what we'd end up when we did our u substitution, which gives me basically 9u to the negative 1 over negative 1, which then translates to negative 9 over x plus 1 and plus c. And so that right there is our final decomposed answer that we're dealing with when we're dealing with partial fraction. So for our next example, this time when we factor this out, we end up with a quadratic factor on the bottom of these, because this guy right here is quadratic. That one right there is quadratic, and so therefore this factors to basically be x times x minus 1, and then we're multiplying it by x squared plus 4, and there's no way I can decompose this quadratic factor, so this is what we have to do. And this is probably one of the worst things we can do to you guys when you're doing these problems, is using a quadratic factor. But here's how it's going to work. The difference is this, that so if you think about this, if I'm doing a derivative of the bottom, I should get a number on the top, or a number when I do the derivative of x. So that's why it's just a single x. And b will be the same way. And so if I took the derivative of this bottom part, I would end up with a number up top. The issue is if I take the derivative of a quadratic function, then I end up with a linear function, and so I have to take that into account, which is why I did cx plus d, and the cx plus d is going to be over the quadratic function. And so that's how we're going to do it, because if I take the derivative of this guy, I should end up with a linear function, and so therefore this is how the setup's going to be, which is a little bit different than what we were dealing with before, but the process is pretty much the same. It just gets a little more complicated when we're dealing with this. So we're going to multiply by the common denominator and set the whole thing equal to the numerator. So a gets multiplied by x minus 1 and x squared plus 4, where b gets multiplied by x and x squared plus 4, and the cx plus d, that whole factor gets multiplied by x and x minus 1. And this whole thing then is equal to the numerator of 2x cubed minus 4x minus 8. And I knew I didn't have to do long division on this one because the denominator has a power of 4, a degree of 4, where the top has a degree of 3. So now I get to start picking some values and try to hope to get rid of some things that will help us. I see if I put 0 in for x, I can zero out a whole bunch of stuff. And so that's kind of where I'm going to start. So I'm going to say x is equal to 0. And so then a gets multiplied by negative 1 and 4. That's a 4, and it looks like a 9, but that's a 4. B becomes 0, which is nice, because that whole thing becomes 0. And if I put 0 in for x, that whole thing, the cx dx becomes cx plus dx. All of that becomes 0 as well. And then over here, this is equal to negative 8. So if I solve this, I have negative 4a equals negative 8. So if I divide, a becomes 2. All right, so keep that in mind. And so now I have to pick another value, and I don't know a best value for this one. Let's try, since I've got these x minus 1s in here, I'm going to try to pick 1 and hope to zero out some things. So putting in 1 into the a value, that becomes a times 0. Putting in 1 into the b value gives me b times 1 plus 4. And then putting 1 into the cx plus d starts out like that, and then that'll zero out the remainder of that. Over here, I'm left with 2 minus 4 minus 8. All right, so it looks like I've zeroed out all of the other stuff except for the b value. It looks like I have 5b is equal to, what do we get when we combine those over here? When we combine them, we end up with, it looks like negative 10. So b is negative 2. And so now that we know what b is, we know that b is negative 2 and a is 2. Well, now we got to find the cx dx. And at this point, there really isn't a logical choice for the next value. You just kind of have to pick something and go with it. So I'm going to try, what if x is 2? All right, so I kind of need to see the problem up here. There it is, the purple. If x is equal to 2, then I just start substituting, so then it becomes a times 1, and I know what a is, so I could substitute in some a, and I could substitute in my a value as well. A is 2, and we get, if I put 2 into the x minus 1, I get 1, and if I put 2 in there, I get 4 plus 4, which is 8. For the b value, if I'm putting in 2, b we know is negative 2, and so it's going to be times 2 and times 8 again. Over here for the cx dx, it's going to be 2c plus d times, now if I put 2 in, I get times 2 and times 1, and then over here I end up with 2 cubed is 8, 8 times 2 is 16, so 16 minus 8 means that this thing is 0 over here. And so then if I solve this, it looks like I've got 16 minus 32 plus, now if I distribute my 2, 4c plus 2d equals that. And so it looks like if I move this across the equal sign, this becomes negative 16. So 4c plus 2d equals 16. And if I divide everybody by 2, 2c plus d equals 8. And so that's one setup that I've got. And so then, unfortunately, I got to pick another x value, and probably negative 1 would be a wise choice, because basically what's going to happen is I still have one equation and one unknown. So the other option is that I go ahead and do this all over again, picking, say, negative 1 for x, and substituting it in and getting another system out of this. So if I put negative 1 in there, a was 2, I'm going to put negative 1, so I get negative 2, and over here it's 5. Plus b times negative 1, and I get times 5. Oh, and b was negative 2, so I can replace that in the problem. That just helps me clean things up. That's a negative 2. And then, since c, we're going to add on negative c plus d, putting in the negative 1, and then we have times negative 1 times negative 2. And then that will equal, putting in negative 1 into all of these guys gives me negative 2 plus 4 minus 8. And so then I'm going to go ahead and simplify this and get another system, and then I'll be able to solve for c and d. So it looks like I got negative 4, that looks like negative 20. Over here, this looks like it's going to be positive 10. This is positive 2, but it goes negative 2c, because there's a negative there, plus 2d, and then over on the other side, it looks like I've got negative 10 plus 4, which is negative 6. All right, so then combining these together and moving it across the equal sign, this is negative 10. I'm going to add 10 across the equal sign, so negative 2c plus 2d equals, let's see, what I said, this was negative 10, adding to 6 gives me 4. If I divide everybody by 2, I get negative c plus d equals 2. All right, and so now that I have this system, I can solve this system and simplify this, so I'm going to rewrite this. So over here we got 2c plus d equals 8, and negative c, I guess I should have left it as a negative 2c. Let's go back, let's just back it up and go, I can use either one of these guys. I'm going to use this one right here, because it already lines up with my c, plus 2d equals 4. And then if I combine these together, adding straight down by elimination, I have 3d equals 12, which means d is equal to 4. And then once I have that, I can substitute it in, and I'm going to substitute it into this equation. So negative c plus 4 equals 2. Subtract 4, so negative c is negative 2. So c is 2. All right, now, with all that being said, we've got a is equal to 2, b is equal to negative 2, a is equal to 2, b is equal to negative 2, c is equal to 2, and d is equal to 4. So now if I substitute everybody in, we got 2 over x, I believe that's what it was, so let's go check back at the beginning here, 2 over x, and we've got minus 2 over x minus 1, and we've got plus 2x plus 4 over x squared plus 4 dx. And so there's my setup for my problem. And so now I get to integrate this thing And when I integrate it, this one becomes 2 times the ln of x plus, minus, sorry, I got my sign wrong there, minus 2 times the ln of x minus 1 plus, now this last one can be broken into two different things that we can take the derivative of because we're adding them together. So I'm going to break this into 2x over x squared plus 4 plus 4 over x squared plus 4, which basically means this guy I can do a u substitution on, which works out really nice. And then the other one over here ends up giving me, this is u prime over u, this one ends up giving me an arctangent. And so this one, u prime over u, basically that is another ln, so I'm going to be left with the ln of x squared plus 4, and then the last one has to be an arctangent, and it becomes plus 2 arctangent of x squared plus 4, I believe, over 2 plus c is what we end up with for this whole thing. And so that is the answer to this antiderivative.